Welcome. In this video I'm going to show you how you can obtain Cramer's V for a goodness of fit test. As an effect size measure, I'm using R and my stikpetR library. I'm using Jupyter Lab with an R kernel of version 4.3, but the R code should also work in, for example, RStudio. This is actually the formula that's being used, but my library has a function that can do this for you. To show you how this can be done, I'll need some example data, so I'm loading in the general social survey data from 2012 adjusted for some example purposes. I don't need all of its data, I just need one nominal field, and the field that I'm going to be using for this example is going to be the MAR1, which is actually the marital status, and I'll store that as a nominal field. To give you a quick impression, the table has been made with 79 people indicated that they were separated. My library is not available on CRAN, so you will have to use DevTools, or another way to install it from my GitHub at stikpet and then stikpetR. Once you've installed it, you can load it just as any other library, and then the function Cramer V goodness of fit will become available. It requires the chi-square value, the sample size and the number of categories as input, and there's an optional Bearsma correction. Now all of that input is available if you've performed a chi-square test or a goodness of fit test with a chi-square distribution. And for example, the Pearson chi-square test of goodness of fit using that nominal field will give you all those results. It will have the chi-square value, the sample size, and it will have the degrees of freedom, but if you then add one you get the number of categories. I have a separate video on this test itself. This video is focusing on obtaining Cramer's V. Once I have those three, I can just feed it to the function and it will actually tell me what Cramer's V is. There's also a function th Cramer's V for rules of thumb for Cramer's V, and that can show you that, for example, this could be classified as relatively strong according to Ria and Parker. You can also convert it using the ESConvert to a Cohen W value, but it also then will need the number of categories. Once we have the Cohen W, another effect size measure, we can use its rule of thumb. And if you like to use that Bearsma correction, just add true, and it should give you the Cramer's V with a Bearsma correction. So that's slightly different than the original Cramer's V, which was 0.401, and now it actually has become 4008, so slightly different. Alright, I hope this video was actually helpful, and thank you for watching.